The BMW's new virtual factory, Halidoy Robotics security robot, two-stage air cabs, construction robots, and other high-tech news in this one episode. Yesterday, on April 19th, the Ingenuity helicopter made its first ever controlled flight on Mars to another planet. The craft, weighing less than 2 kilograms and costing $85 million, took off, hovered briefly, and came back down. Remember that when compared with Earth, gravity on Mars is 3 times lower. The density of the atmosphere is 1% of the Earth's. The daytime planet receives about half the solar energy compared to our own. And at night, the temperature drops to -90 degrees. The Ingenuity received help to take off by a pair of blades spinning at 2400 RPM and 6 solar panels, and most of that energy helps the drone stay warm at night. Once again, Formant invites everyone to control the robot Spot from Boston Dynamics directly from their browser using the WebRTC. All you have to do is go to the site and get in line. There are 90 seconds allotted for each user. But it should be known that Spot has its own work schedule, Monday through Friday from 7 a to 7 p. at the company's office in San Francisco. Before building a real powertrain plant, BMW decided to design it in a simulator with the Omniverse platform from Nvidia. The factory is replicated with all of the production lines and workplaces. The developers say they put workers' avatars in the simulator and built a model of the robot movement to start with. This allows the model to use reinforcement learning, which cannot be implemented in the physical world, and if errors occur, robots can collide, machines and lines can be damaged. But by building a factory in a simulation, BMW was able to test the safety and efficiency of all systems and then transfer them to the real world. By the way, Nvidia dreams of creating systems in which robots would assemble robots, and recently presented its vision of how this could be realized. The model of this course is primitive, but it seems to be just the beginning. Researchers at the Carnegie Mellon University's Biorobotics Laboratory have tested an underwater modular robot to inspect ships, submarines, and pipelines. In the pool, the HUMRS robot showed accurate and smooth movement underwater, as well as a high degree of control. The use of this robot will be making it possible to quickly monitor the conditions of machinery without the use of divers or transporting ships to dry docks. This robot may not look as cool as Atlas from Boston Dynamics, but it's learning to walk on its own without any direct programming. Engineers at the University of California in Berkeley used Cassie's robot and reinforcement learning. In simple terms, the robot learns to walk like a baby, trying new movements and remembering those that lead to a desired result. Over time, the robot refines its skill and gradually gains experience. To avoid breaking the physical robot right away, training begins in a virtual model of the robot, which then transfers its experience to the actual physical robot. So Cassie's able to take their first steps and, as it learns, move and confront the conditions of the outside world on their own. Outside interferences that can't be accounted for, like slippery floors or people pushing or kicking at the robot, are the types of obstacles this robot can learn to overcome. Blogger Michael Reeves has upgraded the robot Spot by trying to teach it to pour a beer into a cup underneath the robot on command. To do that, Reeves needed an extra camera to track the cup's position, a code that allowed the robot to calculate trajectory, and a design for pouring beer. The robot is now at 35% accuracy. What do you think of this application? Are robot pouring beers the future? We somehow missed this news, but about a month ago, a former SpaceX team of developers from the startup Talion Air unveiled a concept for a 2-stage air cab. One stage is the launch stage with a vertical takeoff, and the second stage is the transport stage with horizontal flight. The first stage will be of a twin-beam design with airplane wings. It will get 8 bearing propellers, combined in 2 pairs per beam. 2 more pusher propellers will be placed on the T-shaped tail of each beam. The first stage will have an automatic docking and separation mechanism with the second stage. The transport stage of the Aero cab will be of an airplane design, and it will be able to carry cargo and passengers weighing up to 450 kilograms for a distance of up to 560 kilometers. Cruising speeds of the transport stage will be roughly 330 kilometers per hour. It looks like the Stretch from Boston Dynamics has a competitor. the company Pickle Robots announced a warehouse robot, Dill, which can unload boxes from a truck at speeds of 1,800 pieces per hour against the current 800 pieces per hour of stretch. However, Dill can't do anything else, but it can work with boxes of different colors and sizes randomly lying in the truck and will crawl deep into the trailer as it unloads. The company says the robot is designed to work under human control. That is, because if any unclear situation arises, the robot will slow down so an observer can understand the situation and help the robot out. If not, the robot will carefully continue unloading, reducing its speed to 1,000 boxes per hour. Artificial intelligence and wearable cameras can help exoskeletons act as autonomous robots. Brokoslaw Laksowski, a robotics researcher at the University of Waterloo in Canada, is working on a system that will allow the exoskeleton to recognize its surroundings and decide when to switch walking modes on its own. Brokoslaw is leading the ExoNet project, the first open-source database containing images of human movement scenarios using portable, high-resolution cameras. It contains more than 5.6 million images of real indoor and outdoor areas. Deep learning algorithms use this data to automatically recognize doors, stairs, and other environmental features, and so far, the accuracy is rated at 73%. Haladoy Robotics has shown how its Ever 3 robot can be used to guard offices and shopping centers. However, judging by this video, even to patrol one office, 3 to 5 robots would be needed. At this pace, how long will it take them to pay for their implementation? Ever 3 is positioned as a universal robot for home and office. Haladoy Robotics is not the first company to try to create a nimble autonomous robot for personal and commercial use. Let's see what they make of it in the future. Baubot is also trying to create a versatile robot, but only for construction sites. The mobile platform of the robot is able to move over rough terrain, while the arm mounted on it performs various practical tasks. The full list of applications is still unknown, which is a cause for some skepticism. A universal robot is a very complex system, especially for a field such as construction. Perhaps in the future, the company will give up a lot of applications and focus on the quality of the robot performing 1 to 2 tasks. And that's exactly what San Francisco-based robotics startup Canvas did. For example, they recently received $24 million to scale its drywall finishing robot. The robot combines a mobile base, LiDAR for mapping the terrain, a manipulator, multiple end effectors, and computer vision for spraying and sanding drywall mortar. Aurora unveiled its Odyssey high-altitude pseudosatellite. The solar-powered drone can lift up to 60 kilograms to an altitude of 18 kilometers and operate year-round in mid-latitudes for 6 months in subarctic latitudes. Odyssey autonomously maintains its position for months on end in all stratospheric conditions, produces zero emissions, and is able to conduct weather and climate research, conduct military reconnaissance, or distribute internet. ANYrobotics introduced a new model of its 4-legged robot, ANYmal D, designed for robotic monitoring of industrial facilities. ANYmal D is a turnkey solution for inspections in difficult industrial environments. The company promised to provide more details at its April 27 seminar. Multiple Labs has been awarded $20 million to manufacture pharmaceutical robots. The San Francisco-based company is developing a cloud-control robotic system to produce customized drugs in small batches. The company provides robot manufacturing capacity as a service to biotech organizations, targeting 2 markets: personalized capsules for clinical trials and cell therapies. Robots have begun delivering pizza in Houston. The autonomous Neuro R2 vans move only on private roads. Domino's Pizza customers can track their movements via GPS and receive text messages with PIN codes, allowing them to pick up their order. Neuro has been promoting its robot vans for a long time, but there are few real-world applications as of now. Mobileye is going to equip 35,000 of UDelve's transporter robot cars with its autopilots by 2028, and the first 1,000 robot cars will be deployed by 2023. Mobileye Drive is a Level 4 autopilot capable of independently navigating between predetermined points, bypassing obstacles, and maneuvering in parking lots and warehouse areas. The system relies on 13 cameras, 3 long-range LiDARs, 6 short-range LiDARs, and a single-chip IQ system. The robot car has a maximum speed of 105 km per hour. The ZALA Aero company, part of the Kalashnikov concern, has introduced a drone capable of navigating the terrain without GPS and external control. The ZALA 421-24 is equipped with an individual positioning device that builds a route to the target based on uploaded coordinates. The drone marks its intermediate points for itself and flies by navigating the terrain and maintaining radio silence. At the same time, in any unclear situation or after completing a task, the drone is able to return to the starting position from any place on the route by itself. This makes the ZALA 42124 invulnerable to electronic warfare. Subscribe to the Pro Robot channel, like this video, and don't miss any new releases from the world of high tech.